in order to solve trusses, we first have to solve for the moments that are there. Moment is equal to the force times the distance. So we have a couple reaction forces. We have a pin there, so it has a reaction force A in the x direction, reaction force A in the y direction. Then we have a roller on the right side, so we have reaction force at roller C in the y direction. So the 2 in the y direction help hold the ridge up. The other x is just going because of the pin that's there. So then we got a whole bunch of different forces. We've got the 1,000 pound, the 250 pound, and then the 500 pound, and then we're looking at distances from the rotation. So we got the distance from that rotation. We're going to use pin A as that rotation. So we're going to look at a moment at D because there's a force there. We're going to look at a moment at B because there's a force there. We're going to look at a moment at E because there's a force. And we're going to look at a moment at C because A is our pivot point. So A is stuck there. We're going to try to rotate that down. Think of those 3 forces, D, B, and E, pushing it down, pushing it clockwise. C, trying to push it counterclockwise. So we're going to look at point D. Point D has a force of 1,000 pounds times the distance from that point A is 3. So perpendicular distance. Then B. B has a force of 250 pounds, and its distance from pin A, perpendicular distance, is 5. Then we look at moment at E, which is the force. So we've got 500 pounds of force. Distance of 3 plus 2 plus 2 gives us a nice looking 7. So we've got that. Then we look at that last one. We don't know the force, so we have the reaction force at pin C in the y direction is unknown. And we take its distance. 6 plus 4 gives us a solid distance of 10 from that pin A. So then some multiplication there. We've got 3,000. We've got 250 times 5 gives 1,500 or 1,250. Then we've got 500 times 7, 3,500, equal then our RCY times 10. So yes, if we subtract that other side, it would be negative, but we're kind of just looking right here at the basic numbers. Once we go back into the picture, we kind of see which direction it'll be going. So the sum of everything on the left, 7,750, equal to the reaction force at pin C in the y direction times 5. Divide both sides by 10. We've got that reaction force at pin C in the y direction equal to 775. So after we got that, what we're going to look at over this one and the rest of them, the sum of all the forces in the y direction for us is equal to 0. So we've got these 3 at D, B, and E going and trying to rotate this truss to be clockwise, and then reaction force AY, reaction force CY are trying to go counterclockwise. So the sum of all the forces trying to go clockwise is equal to the sum of them trying to go counterclockwise. So we've got the sum of all of them that are given going down in that clockwise direction is 1,750. And we've got our 2 unknowns, one that we solved for already. We subtract that 775. We got reaction force at pin A in the y direction being equal to 975. So all together, we now can figure out those 2 y's. We've got our forces. Now we can move and try to solve for our joints.